Note, you must know regex to do this kata. That matches any string with at least one number divisible. Matches any string with at least one number divisible by 4 with no remainder. So if there is 8 or 4. In most languages you could do this by using number 4. How would you do it with regular expressions? That matches any string at least one number divisible by 4. A number will start with that and end with that. They may or may not include a plus or minus symbol at the start. This should be taken into account. Leading zeros may be present and should be ignored. There may be other text in the string. Outside of the number, this should also be ignored. Also, all numbers will be integers. Any floats should be ignored. If there are no valid numbers defined as above, there should be no match made by your regex. Here are some examples. That is divisible by 4. Is not divisible by 4. Is not. Is invalid. Valid. Valid. Valid, 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 valid. 2016 is valid, invalid, 0 valid. Note, Mod4 test string will be used, so expression will just need to make a match of some kind. Okay, let's car, train, plane or bicycle. Import re.compile and maybe re return re.o.match .search. So I know what I have to do. I just say rules for division by 4. Are you for real? What is BU? Are you for real? But yo, so now I really want to know what this is about. Wow. Okay. I did not want it anyway. Math, okay. When a number is divisible by another number. 1, 2, 3, 4. There are 3 methods. We present 2 of them. A number is divisible if the last 2 digits form a number divisible by 4, or perform an operation on 2 less digits, multiply each digits. So if the last 2 digits form a number divisible by a 4. So that means okay. There are 3 methods. Well, I want to see the 4th one. So we say if the last 2 digits form a number divisible by 4, or multiply digits and add if the result is divisible by 4. Alright, and then we make an operation with the digits. Alright. How could we do that? If we say 4 or 8, so it's 4, 8. What can be over here is 0, 2, 4, 8, and also 6. So I have to do it in some kind of way like that. If we don't find a third rule, yeah. So the last two digits are 0. The last two digits are divisible by 4. Okay. So here we search. Shit. Here we search with that Mod4 on. Oh, that's a class. Mod4. Oh, we don't even need to return it. Okay. Then we compile something. So we say there must start this and end with that. Must escape this. And there might be some from 0 to 9, and here is plus minus 0 plus 9, 0 or multiple times, and it may end with. Alright, so even this should mark some test invalid. Yeah, we get some green stuff right away. Then we check here. For example, now the alright, it's here, and you can say what can be on the power of 2 decimal. It can be all the way from 1 to 9, or 0, it's 0 to 9. Now the second is a little bit harder, because we need to use the special trick expressions right over here. Token. We need to use like look. Yeah, it's over here. Something like that. Like positive look ahead matches if it doesn't match text. This is a negative look ahead assertion. Have to use like negative look ahead assertions. So over here, alright, so first over here it can be either 0, 2, 4, 6, 8. We test that out. A little bit more tests are green, and now we have to like tackle the final problem. And we can just dump a bunch of look ahead assertions, comment, matches, text, positive look ahead assertion. Matches the contents of the group of the same number. Groups are numbered starting from 1, for example. Matches the 5 5, but not the note the space. Or we can make groups with OR. So to divide that, we can say that's all one group. It's all one group. We put OR in between. If it is 0 to 9, or if it is 1 to 9, first just 0 to 9, with that in group, we get failed 5 past 14. That's 1, and do here OR, so we got 5 failing tests, and here we say 0 and then 4 8. We get okay, even more we get more of them failing, which is bamboozle. Maybe like so. Oh, even more failing now. So if we delete that, there should be less errors. Yeah. We got false should equal true. If we do here 0, false should equal true, false should equal true, false should equal true, true should equal false. Are these randomized tests? No, they're not. So here we are actually the closest to solution. Okay, so Can we see which tests pass and which fail? Because we got, all in all, we got, what, 19 of them, and here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Can we at least, like, we can't even print it out, I guess. So it says type. False should equal true. Is not none. Is okay. Because it can be just... okay, so 0 is also divisible by 4. And we have to put that in, like, these signs. Shit. Okay. So if we just put like question mark over here, zero, it ain't matching it. This question mark is 1 or 0. That is divisible by 4. False should equal true. One test. Oh, look, it's not working. It's calling a match. Oh, that's my problem, because if you search, if you would call a search, yeah, of course, true should equal false. So we do find some false positives. And I understand why are there false positives, so but that's a whole nother issue now if it's using match instead of search. Because in match, what does it say? Because actually here now it's not search, it's match. So here is also match. Run a test. Alright, and here it says if you can say dot multiple or 0 times. Oh, okay. So we're here. And there's this need for negative look ahead assertions, which look like that. If this doesn't match text, this is for example Isaac Asimov will match Isaac only if it is not followed by Asimov. Huh? Only if it is not followed. So if it is, or let's say like divisible by 4, starts with 0, it's 0408. Shit. Like 0408 1216. Oh, and also here it starts with 00 technically. Here is 202428, and then we have 3 2 again. Alright, so we get 02468. I have that. That followed by 0 4 or 8, or where's that question mark over here? It's like that, or like that, and it's 13579 followed by 2 6 yeah, test it out. Is divisible by 4, so it false, so we got first false should equal true. Do these like groups don't work well? Should we wrap that up in one bigger group or what? Ah, nice, okay. So that F test is not by 4. So let's see what kind of is not divisible by 4. false should equal true. What? What the fuck? Ah, oops. Now this test is last here. Okay. Copy. Paste, yeah. No. Is not divisible by true should equal false. 'Cause here it says if it only ends with 4. Okay. Because here, yeah, it matches with this one. I understand the error, and that's more than half done. So how do we do that? Negative look ahead assertion, maybe? Here we save that. That don't match that then with like so. Question mark, exclamation point. And then we say 048. 1. Alright, so that still doesn't work, it still just picks it up over here. So that or or nothing. Because if you cancel this question mark, you can just make one more or just 048, but it must be only one time. Alright, I still see why it's not working, and you may then say, Rook, why then are you writing stuff that you see that are not working? And then I say, that's what I say. So we must just check that this one, like that this does not have this in front. Matches if the current position in a string is preceded by a match for that. Use the search more. Will most likely, but it's not necessary. And over here we say match damn. So you can say match 0, 4 or 8. If the previous thing is that. Oh. Add plus minus. Oh. then over here it can be shit plus minus 1 or 0. All of them pass. All of them pass. Well, thank you for watching this contemplative kata with regular expressions. You got some interesting regular expression. This one is a bit more neater, but it looks similar to ours. Check it out. Oh, we also had some stupid comments over here left over. This is just confusion. This is explaining it. It took me a few hours. Wow, sad face. Still, you know, good job. Well, this kata's taken me 13 days now, for real. And yeah, like over here we got a longer one. Here it starts off the same. It can be and then it can match that 048 or anything in front that's a number and this or that and this or that. Alright, this is a really what we thought, but just written more eloquently and elegantly. So props for this. We can try tomorrow to make this more look like this, or maybe after 2 or 3 days to redo this kata. I am satisfied. I would be somewhere over here, but yeah, I'm satisfied. So that's it. Have a nice day.